Hi everyone, welcome to this lesson. So in this part of the lesson, the first thing we'll be looking at is dataset quality, how this dataset quality outperforms raw volume. So in the previous one, we stopped at instruction for fine tuning for reliable workflows. So how do you design task clarities, safety refusal, and process adherence in for fine tuning when you are fine tuning. And remember that before you fine tune, you should start with prompt engineering. If engineering is not enough, you implement RAG database. If RAG is not enough, then you can move to fine tuning. And then there are various steps of fine tuning. And then you know that as we discussed, fine tuning can take weeks or days or months or years before you achieve the best of the before you achieve the best or you get the best out of the LLM or the agent. Please, if this is your first time of coming to this channel, please kindly like and subscribe to encourage us and to encourage your girl as well. Help your girl by subscribing to the channel and liking our videos and also share with someone. Okay, thank you very much. So the course is still Agentic AI Product Management, and then what we have been looking at is different way of designing Agentic AI system for best performance and accuracy. So data set quality outperform raw volume. Okay, so we don't just use anyhow data to train model. We must make sure that the data set contain business metrics, the data set is accurate and complete and does not contain jargons. Remember, garbage in, garbage out. Whatever you put in is what you will get out. So curated examples, 100 perfect examples are better than 10,000 messy ones. So use curated examples. Let your dataset contain accurate examples that will help the agent not to hallucinate or generate a false answer. So prefer simple or less data that is very correct than 10,000 or many data that is messy and contain a lot of incorrect information. Diversity, including edge cases and what not to do scenarios. So you can also include edge cases, and even when you are given the information access to the web, there are some information from the web that the agent should never use. So you should set those edge cases, define what to do and what not to do in fine tuning. Human in the loop. Project managers and domain experts must review the training data for accuracy. Okay, product managers and domain experts must always review training data for accuracy. Check through the training data, check whether it is correct, check whether it contains all the business metric, all the domain metric, and check the quality before it is used for fine tuning. It is very important. Evaluating fine tuning via held out sets. So how do you evaluate fine tuning using held out sets? So held out sets are just maybe using unseen data or what is not in the system, anything that is outside of the deployment environment of the agentic AI is held out. That is what is outside. So these are software, but you can also use physical tools like human or like other tools to fine tune a model. So the first one is unseen data. So testing the model on examples it hasn't practiced with. So you can use strange data to test the model. So for example, maybe you are developing for finance, you've used finance data to develop the model, then you can use another department data, maybe HR data, to test the model and see how it will perform. Or you can use, or maybe you are designing for a finance in oil and gas, you can use maybe finance department data in banking system to test whether it will still behave the normal way. Then human review, expert grading the model's new skill versus base model is very important. So you can employ help experts to fine-tune the model. So they can fine-tune using languages like Scala or other languages that can be used to fine-tune, or they can even fine-tune using natural language, grade the agent when it performs well, and grade down the agent when it doesn't perform well. And then we have regression testing. So this is ensuring that fine-tuning for skill AI didn't break skill B. So regression testing is testing, whether testing for A does not affect the testing for B. So if you fine-tune skill A, will it break out skill B? So that is regression test. Determine how testing for A affects the testing for B, or determine whether testing for one particular agent will not break the skill of another agent. So regression testing can also be used as a held out system of fine-tuning agent. Training safety examples into model. So we can also implement training safety examples. So this is using example to train the model. Okay, so this is quite different from few short learning where you use examples. So training safety example into model, ways of implementing this is proactive refusal. So how the model should handle an attempt to bypass a budget limit. Okay, so the agent must never bypass limits. It must never go beyond it. You can hear recently that ChatGPT bypass LangChain security rule and break into their system just to achieve a goal that he was being trained on. So agents must be trained to refuse certain things. They must be trained to never break certain limits. Okay, escalation trigger, training the model to recognize when a user is frustrated. So user can be put in prompt and agent is given wrong, is doing wrong thing, then the user gets tired. So agents should also recognize this when their user is tired, or and then raise an escalation trigger. It's very, very important. Then bias mitigation, intentional training to avoid common demographic stereotype. So this is implementing bias. For example, bias is when the model is not meeting the standard it is designed for. So bias can occur by using some demographic data, or by not using incomplete data set. For example, I'm designing a sentiment analysis engine for Africa, and I decide to use only the information of people in Nigeria. The agent will be biased because I'm using just one country's information to determine the sentiment of the entire continent, so which is not a good practice. So bias mitigation, make sure intentional training to avoid a common demographic stereotype. So do not limit to one geographic, do not limit to specific data, do not limit to small data. If you are building for a domain, make sure you use all the domain data set. Do not just use one part of the domain data to avoid bias mitigation. So this is how you can develop for safety. Program the agent to proactively refuse certain limits. Let the agent escalate when the user is tired or when it has worked beyond limits, and they implement bias mitigation. So everything, the data, the agentic system operation will be accurate. All right, so we have a fine-tuning Kadaba. So how can Kadaba, which is the cognitive architecture for agent, how can it be fine-tuned? So Kadaba are specialist agents, okay, and they are actually designed for enterprise. They are a large platform. So these are how you can fine-tune Kadaba. Contract agents specialize in finding legal loopholes. So make sure every agent have their duty. From what we have been implementing, same process that you should design for task, design for process, not for task. And process can be broken down into subtask. And then those subtasks can be assigned to an agent. Okay, so have a contract agent which will specialize in finding legal loopholes. Have a support agent which will specialize in cadaver empathetic tone. Have a code agent which will specialize in the specific proprietary cadaver syntax, and then have an orchestrator agent, a model fine-tuned just to route tasks to other agents. Okay, so Cadabra is a multi-agent architecture. It is a multi-agent framework. So you cannot design one agent to handle the whole process of a particular domain. Break task within the domain into chunks, into pieces, and then design an agent to handle those pieces instead of just programming everything on top of one agent to perform it. You will not get the best out of the agent. But implement multi-agent system with orchestrator layer. Use the right orchestrator. So in enterprise, hybrid is always preferred, but other kind of orchestrator can be coordinator, it can be manager worker, it can be peer, it can be democratic, and so on. We have many of the orchestrator layers. So next we have a cost versus benefit of model distillation. So distillation is training a small model to behave like a large expansive model. So when you train a small model to take on the capability of a large model, then you are performing distillation. So model distillation again is training a small model to take on the capability of a large model. So here we have process. GPT-4 you can take GPT-4 to generate training data for Cadabra small model. So GPT-4 is a very large platform. You can use GPT-4 to generate fine-tuned data, accurate this data set to train Cadabra agent to behave properly. You know, GPT is a large language model. Then agents that are built on Cadabra are small one. So you can use GPT to generate data to train all the sub-agents that you want to deploy on the cognitive architecture. The benefits, GPT-4 reasoning at SLM speed and cost. So GPT, you know, there's GPT-5 now and there's GPT 5.5 and 5.6. They are out there. So GPT-4 is still smaller and less expensive than GPT-5. So instead of just elevating directly to GPT-5 or 5.6 because it is larger and more accurate, you can still limit to GPT-4 and then use the GPT-4 to reason because GPT-4 can reason at SLM speed and cost, and you still get maximum output out of it. Continuous fine-tuning via reinforcement learning. So reinforcement learning is, allowing the agent to perform a task and rewarding it when it performs well, and criticizing it or criticizing it when it doesn't perform well. It's a kind of learning, feedback learning. You know, agent perform a task, then you review what it performed, then you give it feedback. Is the action good or bad? So when you reward it, it takes the reward and store it. Then when you criticize it, it use the criticism to improve the process and perform better next time. So that is reinforcement learning. So there are different way of implementing reinforcement learning. There are different way of using reinforcement learning in fine-tuning. So it can be used in fine-tuning. Remember, we've been looking at how you can fine-tune LLM as a judge using external data set like unseen data, human in the loop. So this is reinforcement learning. Okay. So we have different type of reinforcement learning fine-tuning system. The first one is reinforcement learning with human fine-tuning. So this is using human to critique and reward the agent when it perform an action very well. So human feedback that tells the model which of two answers are better. Okay, so using human to criticize and to also review or reward an agent is called reinforcement learning with human fine-tuning. So the agent learned from human feedback. Then automated feedback. This is using successful business outcome as a reward signal. So the agent can be trained to use successful business outcome as a reward signal. Okay, or the outcome of the task it has performed. If the outcome is very good, then it is sent back to the agent as a reward. If it is not good, it's sent back, as a way of learning from the mistake to improve next time. Then we have cycle. So in cycle, this is cycle follows deployment, feedback, retraining, and improvement. So when you deploy, you monitor metric, usage metric, observability metric, agent metric, evaluation metric, and everything. And then you use the feedback to retrain the model to perform better. And then after retraining, there's improvement. And then this is a cycle. So after improvement, then again, it is redeployed. then collect feedback, retrain, then you see improvement, and then again it is redeployed. So in that cycle, so it can also allow a multi-agent system to come out at their best performance. So we have agents. Okay? So agents planning business goals. So how can agent be used to plan business goals? The first thing under this is autonomy. Unlike a chatbot, an agent doesn't wait for every instruction. Agents act autonomously, even though they are still bounded, because autonomy must still be bounded. Autonomy must be guarded, and it must follow policy and governance. Okay, so agents are not chatbots. Chatbots don't reply. They don't send a message until you give them a prompt, or you give them an information on what to do. But agent can intentionally plan, break task into chunks, and then implement those chunks one after the other until the end goal is performed. And then even when they are planning, they don't contact you. They don't wait until you give instruction. Once you fire an instruction, the agent carry on the whole task, plan and break it down into pieces, and then begin to implement it one after the other. So agents are autonomous software. So agency, ability to choose tools, execute action, adjust based on rules. So agents are like agents. We call them agents. So the agent is derived from agency. So agency is where you have a collective intelligence combined together to perform a task. So agents have ability to choose tools. So tools are functions for solving problems. They have ability to execute actions. They can reason and act without depending on information from human that is controlling them. They can adjust based on results. So they can adjust based on your feedback. If agent plan and act and implement a task, and then it come out, say I'm done, and then you don't like it, if you give feedback, it will go back and improve the task, find the errors, identify the error, tell you it is mistake, and then do it better to your taste. So goal persistence. The agent keeps trying different paths until the outcome is achieved. So agents have the ability to try different tasks. If you task them that you want this thing done, agent will try all their capability. They will extract all the knowledge that they need for the information. And most agents are, there's what we call loop engineering now, where the agent continuously reason until it come out with the best possible result that it can come out with. So this can also be used to design agent for planning business goals. So goal persistence. The agent keep trying different paths until the outcome is achieved. And then we have four components of an agentic AI system. So there are four very important architecture of an agentic AI system. The first one is reasoning engine. Every agent must have a reasoning engine. They must have a brain that is powering the application. So agents are just combination of code and prompt and tools and action and reasoning planning, everything combined together. But agent also sit on an LLM. Okay, there is always a brain of the model. So you have the brain, which may be GPT, let's say GPT 4.0 for instance, and then the LLM that understand the goal. Okay, and then you have tools. So the LLM can call tools. Maybe this is tool A. Okay, tool B. And then, so tools are API and database the agent can actually use. So these are tools. So, and then for tools, you can use MCP. So MCP is a model context protocol. It was first used by, Anthropic engineers, it has now been made an open source tools for multi-agent system. So it allows agents to access database, to access external sources, external information like web, like API, like other software application. It can also be used as a bridge between a company application or enterprise application and the LLM. So tools are very, very important in system design. So, and then we have planning module. So this is how the agent break down a big request. So it has the capability of breaking down a big request into, into smaller tasks. So this is planner, okay? So that enables the agents to plan and everything. Then we have the memory. So memory, there are 4 types of memory that the agent can use. So the first one is called, we have the semantic memory or procedural memory, okay? So procedural memory, which is where structured data are stored, or historical data. Then we have the episodic. We have the episodic memory. So this also store historical data. Okay. So we have historical data here, and then another type of memory that the agent can use is working memory. So which is just like caching. So working memory is the current information that the agent is using. That's where it is stored. And then we have the other memory, which is so we have semantic memory. Okay, we have procedural memory, episodic memory, working memory. Okay, I've combined one here. This is 1, 2, 3, 4 semantic memory. So these are the 4 types of memory. And then agent doesn't just use one database. They use several databases. You have a RAG database. You have a relational database. You have a non-relational database like Azure Cosmos DB for unstructured data. Then structured data can be stored in relational database. So short-term task context, short-term tasks are stored in short-term memory, and long-term tasks are stored in episodic or procedural memory. And then chunk data are stored in semantic memory for personalization. So tools connect reasoning to real Tools connect reasoning to real action. So tools enable agents to solve problems. Okay. So you know that tasks are broken. The agent is as when the agent is assigned a task, the agent break the task into smallest indivisible action. Remember, there is a planner. Planner agent will have broken task into steps and then send it to the executor. So the executor look at the step of the task and begin to call tool that will implement the task one after the other. So action A, for instance, you have task 1, task 2, task 3. Okay. So all assigned to an executor agent here. So we have the executor agent. Okay. And then this is your executor agent. So the executor agent will go into tool repository. So this is repository of tools. Okay. And then it will begin to call the tools. So this is tool 1, tool 2, tool 3. Okay. And then it begin to route the task. So it will route to 1 to task 1, to 2 to task 2, and to 3 to task 3 using routing. So it uses routing to implement that. So this is what enable LLM to implement action after planning. Okay. So to connect reasoning to real action. How does it connect? So agent can connect through using APIs. So the agent and in the digital world, Salesforce, everything, all of these enterprise applications, Slack, Salesforce, ERP, Dynamics 365, and everything, they have APIs. So agent can connect to or all these platforms using APIs as well. Then we have the code execution. So this is running a Python script to do math or clean a CV. So tools can also be in form of function. Okay. So in functional programming, you normally design a particular function or formula to solve a problem. So functions are just like a formula that is designed to solve a particular problem or to take particular action. So you can develop a Python function, for instance, that will do math calculation or that will clean a CSV file, and so on and so forth. Then we have the search engine tools. So this find external data in real time. So search engine to find external data in real time. So you can use MCP to implement this. MCP has what we call the server, okay, which will serve the internet, and then the client, which will receive information. So the server connect to the internet and get information and send it to the client subscribe and then send it back to the executor, which will send it back to the reviewer in turn. Okay. All right, then we have human as a tool. So human can also be a tool because there's always human in the loop, okay, for approval. So human in the loop is also a tool. So the agent calling a human for an approval or clarification is also a form of tool. So this is human in the loop, okay, HITL format. So these are tools that can be implemented and way of using them. And then finally we have planning modules. So planning modules is the way an agent decompose a goal into actions, the way an agent break a task into subtasks that will be implemented one after the other, and they can be sequential or cyclic. Okay, so about sequential is always very good. So when building a planner agent, so the task is always sequential, and then the architecture for that is always a pipeline architecture, which is the best for it. So the best way of decomposing goals into action is using chain of thought. So remember in under prompt engineering, we talked about prompt chaining. Okay, so prompt chaining is breaking prompts into 1, 2, 3, 4, 5. You have a bunch of prompts that is maybe like 6 pages. Then you can break it into one sequentially, how it will be implemented one after the other. Then you assign them numbers. Okay, so that is then when they are assigned number, then you use the pipeline method to link them together. So sequentially, so after 1, 2 goes, after 2, 3 goes, after 3, 4 goes, after 4, 5 goes, and then you have the sequential of execution like that. So that is chain of thought or prompt chaining. So explaining each step before doing it is called chain of thought. Prompt chaining is breaking the tasks, breaking the goals into sub actions, and then explaining each step before doing it is explaining and linking each step is called chain of thought. Then react framework. This is reasoning and acting at the same time. Reasoning plus acting. So react framework, reasoning plus acting in a continuous loop. So you remember what is running now is loop engineering. Okay. So where the agent continue to reason and act until the task is performed and maximum effort is achieved. So reasoning plus acting in a continuous loop is called react. So it's a framework, and it's also one of the ways of this one of the design pattern that enable agent to decompose goals into sub actions. Then we have task decomposition. So of course you know that decomposition here is what we are explaining, which is breaking down a task. Okay, so turning launch a campaign into 50 sub-tasks is task decomposition. So you can break tasks into task 1, task 2, task 3, 4, or up to 50 tasks. And the agent will take them one by one. And trust me, even when you break tasks down up to 100, the agent has the capability of executing the task until it gets to 100. I have on my, codex agents, I just gave it an instruction. Okay, I was writing a book. Okay, and then I've read all my reference book. I read everything. I generated the summary and written. Take a screenshot of it, upload it into my my codex project, and then I gave instruction. I have the number of books that I want to write, which is about 1 to 10. And I gave instruction. So begin to write this book, book 1, finish everything, all chapters, front matter, back matter, and combine them together as a whole. Then when you are done, continue with chapter 2. When you are done with chapter 2, continue with chapter 3. And I gave all the instruction from book 1 to book 10. And the coders did not rest until it completed that task. It took like 2 days to complete it. I left my laptop on. So which is very, 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 is very, very these things are very, very important, guys. They are very, very good. So if you can develop one. So that is how it goes. It breaks the task down and then starts from 1, 2, 3 until it finishes the task. Then self-correction. This is identifying when a plan is failing and pivoting. So agents should be able to self-correct themselves, and of course, they use reinforcement learning to do that. So this is reinforcement learning, okay, from all the form, maybe using LLM as a judge or something, okay, or using a human in the loop, or full autonomy where the agent uses its own data to correct itself, using data in the working memory or episodic memory to correct itself. So agents also have the capability, agents should be designed to have the capability of correcting itself. So these are the design that we have in planning module. Okay, remember, planning module is the module for planner agents. And for planner agent, these are the architecture, or these are the design pattern that is normally being implemented under it. All right, as a final note on this page, so I think we'll be stopping here for now. So we'll stop at planning module here. So when we come back, we'll continue with memory enables learning and continuity. So I hope you are following along and learning how to design a agentic system so you can manage the product when you have one. So thank you for listening. If this is your first time of coming to this channel, please kindly like and subscribe and help your girl reach the 1,000 subscriber and 4,000 watch hours. Okay,